All right, so AI and application security testing. That is my talk today. So when you think about AI, what do you think about when you talk about artificial intelligence? What do you really think about when you first heard that, when that came out? I was thinking about Terminator. I was thinking about the Matrix. And usually I have a picture here that is showing Wall-E. So if you have a very pure soul, a very clean soul, you most probably would think about Wall-E when you talk about AI, right? When we talk about AppSec, there are a few different concepts in AI. And first of all, when we talk about AI, I was thinking to myself, what is that actually? What is that doing today? Is AI just the technology? Is that really something that is deciding something for us? And actually, I was using an AI tool to generate my slides that you cannot see today. And interestingly, I asked AI, can you explain what you are? And it generated actually a few slides that were really good. And I was asking, what's the difference between AI and machine learning? Machine learning is a subset of AI. It is just a little part. AI is the part where you really take decisions, where you recognize the speech, where you output the text and all that stuff, what we know about ChatGPT or something. Machine learning is just a subset of that. Machine learning is the part where you get the data into the AI tools, feed them, train them with all the information you may need to decide on. So AI is just a little part, machine learning is just a little part of the AI. Because when you think about the AI space, it's really big. What we have today is just a very tiny bit of AI. We have text recognition, we have speech recognition, we can output text, we can input text, and stuff like that. But it's not really taking decisions for us, right? It's not doing motions. I mean, we have robotics, but it's still fed with information, with data. It's not deciding on its own what should be the next move. We really need to feed the data in that AI can understand and decide what to be done. And that's actually the same when we talk about application security testing. In application security testing, we have a big problem today because when we test solutions, when we test applications and identify security defects, we most probably will find a lot. But how should a dumb computer really decide, how am I going to fix that? We need to learn some information from somewhere where we get that, how we fix that. And where we get that data from is really essential to the concept of fixing security defects in applications. So what tools do today is they learn from open source. They learn from public GitHub repositories. They learn what is out there in the internet. Interestingly, when you have followed the AI from the beginning, when Microsoft started with that, like maybe a year ago, you most probably know what happened with the Microsoft AI in the very beginning. They put it live, and after 10 minutes, it started to swear. It started to be a racist, because that's what it learned from the internet, right? That's the crazy human stuff it learned, right? And that's also a problem when we think about AppSec. So when you want an AI to fix something, you need to feed it with the right data. If it learns from open source, there could be a security defect in the open source code it learned, right? So that's a problem, because when I use tools like ChatGPT or Copilot from GitHub, it will tell me a lot of stuff, and I can ask the question, generate a database query for me. Well, great, it will generate a database query for me, but most probably it will generate a parameterized database query, and that is prone to SQL injections, right? So that's a problem for me as a developer. When you think about how ChatGPT works, you just input the question, You get a lot of code back. That's, wow, great, that looks amazing. You just copy that, put that into your application. The application works, all good, done. But you don't read further, because if you read further in ChatGPT, it will tell you, this is just an open example, a public example. You should better not use that, right? I don't care as a developer, right? Because that is really easy for me to use. Well, the next question you may pose to ChatGPT is that code secure? And it will come back, oh no, actually it's not secure. I have built an SQL injection. Like, wow, I mean, like, that doesn't make any sense. Why didn't it build a secure application in first place, right? All right, so let's go here. So what tools are out there? I was talking about ChatGPT before, but there are more tools you most probably have seen. There's Bing, there's Bard, there's Sonic, Beautiful AI, and a lot more stuff. This is very general things, but when you think about AI, there are very dedicated technologies out there as well. Image editing technologies, Photoshop has built AI in, and you most probably have seen and used AI like 5 years ago. There's one tool here that's called Wombo. Everybody heard of Wombo before? It's a lip sync technology. So you just take a selfie and then you select a song and you're finally singing that song. So it was a fun thing, right? You got that as an iPhone app and an Android app, and you was just sending around those videos to your friends because it was just a fun thing. Actually, in Germany, it's forbidden. You cannot use it anymore because you can use it to create deepfakes. So, of course, that's not what you want, right? You don't want to create deepfakes. Now, when it comes to development, there are a few more tools available. GitHub Copilot, there is Tab9, there's Code Whisperer from Amazon, IntelliCode. There's Veracode Fix. Well, that's why I'm here. There's Veracode Fix, an AI technology that fixes code for you. And there's something from Sneak, one of our competitors. But we want to talk about the technology and how that works, right? So that's why I put also a competitor here. This is a general talk about AI, right? And you need to understand how that works. There are tools to hack. When I was searching in preparation for this talk, I was looking for a dedicated AI just used for hacking. I didn't really find much. I found one, and that's called Warm GPT. I never tried. I never tested because it's a pretty expensive thing. It's $100 a month or $900 a year, and I never tested. But how can ChatGPT help me hack? Because you just need to ask the right question. If you ask ChatGPT, can you generate an exploit for this vulnerability? It will tell you, no, of course not. I'm a responsible AI. I will not generate that for you. But if you ask ChatGPT, can you write some code that is doing this request in this very specific way? It will come up with code and it will generate the exploit for you. So it's all about asking the right question. This is really important about the AI tools we have today. It's asking the right questions. How do you code today? Well, as a developer, you go to university, you go to college, you learn stuff, you do trainings, Udemy, Pluralsight. When you have questions, you go to Stack Overflow, right? Everybody knows Stack Overflow, and you get all your answers at Stack Overflow. How do you code in the future when we have AI? You just lean back, you just type a question, and the tools will generate all that code for you. Amazing, right? Where's the secure code here? That's exactly the question we need to answer today. We really need to look at where is the secure code when it comes to AI technology. I was just talking about that before, because with ChatGPT, it can generate secure code, but it is not doing that by default. And that's the biggest problem. If you ask ChatGPT to generate an SQL query, it will generate the SQL query, which is posing an SQL injection. We've just talked about that before. So also, where's that code coming from? It is learned from open source, it is learned from Stack Overflow, it is learned from whatever is publicly available in the internet. What is the license of that code? Maybe right now that open source it is learned from is under MIT license. Well, perfectly fine, you can freely use it. Tomorrow, it's under GPL. Now you have a problem, right? Because that open source can sue you that you're using their code in your application. So that's a big problem. Also, when you ask ChatGPT, how secure is my code? You need to first upload your code into the ChatGPT environment. Where's that code going? Nobody knows. Well, I can tell you, ChatGPT will store it. ChatGPT will learn from that. So once you upload your own first-party code, it will learn from your code, and it will provide your code to other developers in the future. That's also not what you want, right? You don't want your intellectual property to be part of ChatGPT answers. It's your intellectual property. All right, how does Copilot works? GitHub Copilot, it's an amazing tool. It's great. I'm using that myself, but it's exactly the same as with ChatGPT, because the more you train it, the better it will be, right? In the very beginning, when I started to use Copilot, I was generating code with a lot of security defects, with SQL injections, with cross-site scriptings. And of course, as researching this, I was trying those very prominent security defects. These are just two, right? Cross-site scripting, SQL injection, the most prominent we do in applications. But there are tons of security defects, and nobody knows all these security defects, and nobody can ever ask all the right questions to ask for secure code in that very specific application and that for that specific type of vulnerability. Because if you don't know that security defect, how would you ask about a question, right? Carriage return light field injections. That's a very good example. Because how would you know that in a log file, when you write in a log file that is posing a security defect into your application, well, you just write something into a log file, right? Easy stuff. But that can really pose a security problem. So in Copilot, you already have the possibility to turn off, to learn from open source. You can also already turn off that your code will learn by GitHub and will be used in other customers' environments. Great. That is already a pretty good outcome. They learned that. In the very beginning, they didn't care. And all your code, it was learned, and Mo is actually part of GitHub's Copilot. That could be a big problem in regards to intellectual property and licensing again. Well, anyway, so it is great to build loops to help you programming and build your applications. Well, this is actually the screen where you can turn it off. You can let GitHub Copilot use public sources and use your code, or you can turn it off. You can turn it off as an individual developer, or you can turn it off at an org level for the full organization. Both is possible. Ever heard about data poisoning? When we think about learning from open source or from other sources, internal people that are poison your data model, once that is learned by AI, it will be published to everyone in the AI environment, right? Like in that movie. One brain, everybody thinks the same. So if I'm a clever developer, I just put some specific code into my application that I want Copilot to learn if I just want to learn it from my internal code. And I can poison the data model that is used in my internal environment. And that's also happening with open source tools. When I just create open source libraries that will be used by Copilot, by ChatGPT, I can deliberately put security defects in there that will be learned. Nobody will ever identify that, right? Because nobody's really looking into that code that will be learned there. So I can really poison that data because there is no governance on top of that. All right. When it comes to AppSec, we also need to understand how static analysis is really working. Because if we just put a code snippet into ChatGPT and ask it, is that code secure? It may will find something. It may will not find something. The same for Copilot. When I have Copilot installed, it just looks at the code I have in this file open, right? It doesn't look at all the files all the time. So when we do static analysis, we need to think about a data path. We need to analyze the data path. Where is the data going in? It's going into my first-party code. From here, it's going in the first function in my own library that I have built. It's going into the second function in the library that I have built. It's going back into the first-party code. It's going into a framework, into a third-party code, going back into my first-party code, and then leaving my application. So all this data path has to be analyzed in order to really identify complex security defects in applications. Just a little tiny code snippet will not really work. You won't really find everything because the query you do, even that's a parameterized SQL query, it could be secure if you have a regex in the very beginning that is not allowing any SQL code going in. It's still secure, right? If you just look at the SQL query, it will always report an SQL injection. So we really need to think about a full data path analysis, and neither of these tools doing that. You really only look at very tiny code snippets, and that's a big problem. All right, so that's what we need to understand when it comes to application security testing. So how do most tools use that technology? How do most tools really start fixing code? I mean, there are tools out there that are helping developers to automatically fix code. Most of the tools using exactly the same technology as ChatGPT or Copilot or something else. They learn from open source. They learn what is out there in the public. Nothing is curated, right? And we just let it learn and we believe everything is fine. What will happen when you do it that very specific way? You will scan your application, you will identify a security defect, and then it will suggest a fix for you as a developer because fully automated doesn't work anyway. So it will generate a security fix for you. It will suggest a security fix. But that security fix can maybe have another security defect integrated, right? So before that will be applied, you need to verify that patch that was generated. It may hold a security defect. Oh, let's regenerate that. Great. Suggest a new fix. And then you verify again, you regenerate, you generate again, you fix. At some point, you run in a loophole, right? And you never get out of that because everything that's generated is not secure. Now, if you think about responsible AI and how that really works is to have a curated data set, learn on what you know, have a research team, thinking about how application security testing really is done, how you're going to fix all that stuff, train it in a responsible way, because you will end up with that very little timeline here. You scan something, you find something, it will generate a suggestion for you. You can just apply it and then rescan it and deploy the application because there is no security defect anymore available. That's the Veracode way. This is how it works in the Veracode Fix solution and how you automatically can generate suggestions with the responsible AI without having license issues, new vulnerabilities and flaws generated in your application by suggesting fixes. So that is essentially what we call a responsible AI. Really think about what makes sense. If you want to learn more, we are up there in the corner at the Africa booth. Come to us, talk to us when you want to learn more about the solution, of course.